Hello, friends. Couple of weeks back, I discussed something about uh, using Photoshop to generate LED bulb patterns or PWM pulses. So, in today's section, we are going to discuss how to do it. So, this discussion consists of two parts. The hardware part, that means preparing the Arduino Nano and the program for the Arduino Nano. And the second part is the creation of the C# application to generate the pattern C file. After that, that C file can be imported to Arduino program and compile it and upload to the processor. So in order to do that, let's do the initial configuration that consists of connecting the Arduino pins to the relevant LEDs and preparing the circuit. So let's go outside and let's prepare the circuit. So friends, these are the equipments that we require to build this circuit, or rather hardware. So this is the Arduino Nano and this is the old version of the Arduino Nano. So you have to do some configuration changes in order to upload to this version of Arduino here. And also these are the 8 LEDs along with the 100 ohm resistor here. This will be the common resistor, and these are the ribbon cables, and this is breadboard. So you may be wondering why I have these wires, whereas I can directly connect this Arduino to this breadboard. Well, the problem is this breadboard is low quality. As you can see, this side is also started to remove. Alright, so when I try to push this in, these connections fall off. Therefore I cannot use this Arduino board directly to this breadboard. Therefore I have to use these connectors. Right, so let's do the connection right now. So friends, in this Arduino board, as you can see, we have these pins, right? So we have G and D, D2, D3, D4, D5, D6, D7, all through D12. Here we are going to use 8 LED bulbs, so we should need 8 digital pins. So I'm going to use 2, that means our first one, and 3 second for third, fourth. So fourth one is this one, the D5. So altogether I am going to use from D2 to D9. So we have 1 2 3 4 5 6 7 8 LEDs plus one ground. So we require a ground, so I'm going to use this ground. So let's start connecting these from ground through D9 to this pin with this ribbon cable. So let's start now. So sorry, here's a G. All right, so my final line is D9. As you can see, this D9 is connected right here. So the GND is connected right here. Okay, so my GND is the white one, so this is the other end of that. So this is the other end. So I'm going to connect this GND to this side, this minus line here, like this. Looks like this low quality here, so I'm going to connect like this. So, and this is my resistor here. Alright, so I need the resistor to be connected first, so let me connect GND like this. Alright, this is my GND. This is my GND, and let's connect this resistor like this. Alright, so right, I have this resistor connected now. uh, now from these wires, this is the first bulb, second, third, fourth, fifth, sixth, seventh, and finally eighth. So these are the pins that goes to LED bulbs. So let's connect LED. So this is the ground side. So this side goes to minus like this. Let's connect these two also. Right now let's connect the positive signals here, starting from this line. So let me turn this around. So I already have the ground connected, so I'm going to directly connect these two straightforward connections. So nothing much here. Right, all the pins are now connected. Now let's see if the circuit works. So let's try the connections now by giving the power to the circuit. So this Arduino board has the pattern that we programmed last video, so it should run here, right here. So let's check the connections now. This into right, as you can see, we have successful connection. As you can see, these LEDs are working. Looks like we have one LED is having issue, so there's a small connection issue there. So let's connect that. Right, the pins are interchanging this LED. Alright, so this LED should connected like this, so we misconnected this one, so let's reconnect this. As you can see, all LEDs are now working as expected. So right, so this is the connections. Now these are working. So now let's start programming these Arduino Nano in order to accomplish the PWM pulses. So friends, we have completed the hardware wiring part, and now we are going to develop the firmware to the Arduino program. So we selected the firmware part today. That is because the next part, the C sharp part, depends on how our firmware behaves. Therefore, it is a good idea to develop the firmware first and then go to the C sharp program. So the C sharp program can behave the way what we want it today. Alright, so without any further ado, let's get started. So let me start my Arduino program here. So you need a library called soft PWM because you are controlling multiple PWM pins here. So it is better to use soft PWM. Therefore, I'm going to use the soft PWM in our program. So in my version, in my Arduino, I already have the soft PWM installed. So if in your ID, if it's not installed, so you can install it by going to tools. Sorry, not the tool. It's in Sketch, include library, and then go to manage libraries. All right. So let me click the manage library here. So you can see this dialog box popped up. In here, once it's completed the refreshing, what you can do is you can type soft PWM right here. So let me type soft PWM here, and it searched for soft PWM. So as you can see, it states already installed in my machine. So if you want to install, you can install the version you want, but I'm not going to do the same process again. So here in my case, it's already installed. So I'm going to close this one. So here, this is the circuit that we prepared in outside. Alright, so this is the Arduino Nano with the old firmware version, sorry, bootloader version, and this is the actual LEDs. So as we tested earlier, these bulbs turns on when you plug this into the 5-volt line. Right now here, let me put it back. So here I'm going to use tools. So I'm going to select the board to Arduino Nano. You can see I already selected the Arduino Nano, and the processor is at Mega 328P. Make sure you choose the old bootloader if you are using an older version of Arduino Nano. Alright, if you are using a newer version, you can just go to 328P. In my case, I'm using a old one. This is a couple of years back. So therefore, I'm going to use 328P. Alright, so now let's do the initial PWM configuration in this program. So this program is you can see there's nothing here. So let's start implement one by one. So here I'm going to start by including the soft PWM library by using #include so soft PWM.h here, right? So let me save this PWM, right? So let me check the compilation whether this file is valid. All right, so as you can see, there is no errors. All right, so now I'm going to use a PWM begin here. So I'm going to use soft PWM begin. All right, so this will instruct the soft PWM's library to start its activity, initialize the activity. All right, now you remember when we are connecting to the Arduino code, the pins, we use pins 2 through 9. So we have pin number 2, 3, 4, 5, 6, 7, 8, and 9. So here I'm going to initialize all those pins as PWM pins. So here I'm going to use soft PWM set. Alright, so first we need to specify the pin number. So 2, 0. So let me copy and paste. So let's check our syntax. As you can see, everything is correct. So for now, I'm going to check whether our PWM is working or not. Alright, so again, soft PWM set is the one that we are going to use here. Alright, so now I'm going to use, let's say I'm going to use pin number 2. So in this soft PWM we have 0 to 255. So the lowest one is 0, the highest one is 255, meaning 0 is the turn off state and 255 is the most brightness, which means fully on state. So let's see soft PWM set. So let's see 2, 255. If I connect this, so I'm going to connect my Arduino here. Connect. Right now, virtual machine. So you should connect to virtual machine here. Alright. Okay. So now the device is connecting. So as you can see, these LEDs are running. So as you can see, a small reset here. The reset is due to the fact that the USB device driver resets the Arduino, and at that time you will see small resets. So let me put those pins away. So this is the last pattern. So let me go ahead and upload this one. So let's see what we can have. So let me correct the port here. It looks like I have port problem. So I have COM5, which should be COM5. So so as you can see now it's turned off. As you can see, the PWM pin number 2 now is high. This is our first LED. So it's high, so let me set to, let's see, 10. It should dim. Let's see. Alright, you can see the LED is turned off. So as you can see now we have low brightness. Alright. So here, now let me check for other ones. So let's say 9 and 128. So I'm just going to check these and let's do the implementation after that. So the LED is turned off. Alright, as you can see, the LED is turned on. Now the 9 LED, that means last LED is turned on. So 8th one, 1, 2, 3, 4, 5, 6, 7, 8. So this one turned on. So now we can do the program of the first part. Alright, so let me put it away. So now we need function that get the next pattern from this our Photoshop program and displays here. Alright, so in order to do that, let's write some function. So let me include a new file. So this is my main project directory. So I'm going to create a new file here. So I name this as pattern.h. Alright, and let me close and reopen the Arduino IDE. So this one gets refreshed. Sorry. Alright, so we should see the pattern.h file. Alright, here is the pattern.h file that we discussed. So let's define the initial configuration. So if and def, I'm going to include the patterns here. Okay, so we need a method to get the next pattern. Alright, so we are going to use a what we call a multiple dimensional array. So basically we are going to use two-dimensional array for this one. Therefore I'm going to use a char pointer to a char, that means unsigned byte rather, but we are using char here. So I need one to get the address of the, so not the address, index of the first row of the LEDs. So for that one, I'm going to use a function which it return type is char pointer. So char pointer next pattern. Alright, so this one is in our pattern file. Alright, our goal is to get one pattern from our PWM and display it and then go to next pattern after a delay. Alright, so that's the main idea our case. So let's delay some, let's say 25. Alright, now talking about delay, we have to take into something consideration. Alright, so we need to specify how much pattern, what is the refresh rate for each pattern. Alright, so here I'm going to use 25. Alright, that is because so 25 this is milliseconds, so 25 milliseconds into 40 we have 1000 milliseconds. Alright, so I delay 25 milliseconds here per each pattern, rather each single pattern. Then for 1 second I display 40 patterns in the C file, C++ pattern file. Therefore, 25 into 40 creates 1 second. So, when we are developing the C sharp program, or rather we are drawing the pattern in Photoshop, the 40 pixels to horizontal side means 1 second. Alright, so we'll discuss in that in next section. So I'm going to delay 25 milliseconds here. Alright. So here I'm going to use now now I need to get the pattern. So I'm going to use char. So this is the pointer to the char. Pattern equals next. So here, as you can see, if I try to compile this, we will get an error saying that undefined references because this next pattern does not have an implementation. So you can see undefined reference. So, that's it. Let's ignore that for now here. Okay. So assume that we have that function implemented. All right. So we have a pointer. So now we can get the values from this point. All right. So I have LEDs. All right. So I have let's say 2 to 9 LEDs. Right. So before we go further, let me declare some array. So this is integer array. So this integer array holds the pins. That is because we are going to use for loop in order to light up the LEDs. All right. So when we are using for loop, we need an array to address the pins. So I'm going to use pins here. So these pins are array which is equals to 2 through 9, 2, 3, 4, 5, 6, 7, 8, 9. So this is the first LED, and this is the 8th LED. So 2 through 9. Alright. Now here we can simplify this. So I'm going to simplify this code. Remove this one, and I use star pins plus I. Alright. Pointer. So initially I said this one. Alright. Now we discussed when we are demonstrating that video last couple of weeks back. We said that we should use program in order to accomplish this because the patterns are lengthy and we cannot use internal memory in the Arduino Nano, and that is because the internal memory is not much in the Arduino Nano. Therefore, we must use program. So we need to get the values from program to these pins. All right. So unlike in ESP8266 we did program there also, this Arduino Nano has a different way of getting values from the program, especially with multidimensional array. All right. So now I'm going to implement how to get the value from the program. So first of all, let's use our for loop here. This is equal to 0, and again is less than 8, then is I plus plus. Alright. Now we must use this function. That is because we are setting the PWM value now here to this actual pin. Alright. Now here the pin number is this one. This part is same. Alright. So after the comma is the part that get different. Alright. So this one is same. Now after the comma we are going to use PWM read byte near. Alright, PWM byte near. Now we need to pass this pointer to get the value from this one. So we are going to pass the memory location of pattern and its index. So let me check the brackets here. So I have one open bracket, two open bracket. I have no bracket problems. Let's compile this and try again. Alright, I have this error here still. That is this error. Let's implement that function. Alright. So here now I'm going to create another file called pattern.cpp. Alright. Alright, now this is CPP file, so I'm going to close this Arduino IDE and open that one again. Alright, so now as you can see the CPP file also there, so I'm going to include pattern.h here again. Now I'm going to implement the next function. So this is responsible for giving you the pattern. Now if we try to compile this won't, this may throw error saying that return type is not matching. Alright, so this compiles without an error, but you know there is no return type here, so we should not run this at any cost because this may generate some unexpected result. Alright, now here let's so now let's hard code. All right, let's hard code some value, so not some not a value, a pattern that lasts for 1 second. All right, so as you can see the 1 second is 40 units long, so 40 milliseconds, sorry, 40 into 25 milliseconds means 1 second. So let's get a 40 lines to create some random pattern. Or let's light up everything and slowly light up everything and slowly light reduce the intensity. All right. So let me create initial variables here. So I need something to hold the pattern number here. All right. Alright. So now this is the pattern. Here we are going to use program here. Now this is multi-dimensional array. Alright, now let's do 40 here. So 1. Now let's go from 0 to 255 and come back to 0. So 0, yeah, I'm going to come 0. So 1, 2, 3, 4, 5, 6, 7, 8. And here I'm going to again come back to 0. Or maybe we may not need to come back to 0. Right, let's go. So I'm going to just fill this pattern here. Alright. So after let's meet after this filling. Alright, we filled the pattern. As you can see, I filled with these two everything here. Alright, so let's try to compile and see. Alright, so we have error here. So alright, this should be uint32 underscore t. Let me correct that. uint32 underscore t. Alright. Right, so basically I believe we need some okay, just put this one and we are good to go. Alright, now here we have 40. Alright, so if we here we have this line is 7. So if we go further, We have 46, 40 here. Alright, now we have 40. Right, now let's get the working here. Alright, now first we must check our pattern. So this is pat ID. So if, alright, so this one is equals to 40, then immediately we should set it to 0. And we get the pattern. So we are going to return the actual pattern here. So let me get the variable here. So we are going to return the pointer of this one. Alright, so 0 to 39 here. Alright, so when this one is 39, alright, so if this condition going to be false, alright, then it gets the 39 from here and returns. Alright, so we are going to return the pattern. So now we return, but we should increase this before return. So now here 39 becomes 40. Now there is no 40 here. When this one gets called again, the 40 is going to be 0 and it jumps back. Okay, let's compile this and let's see. Alright, seems to be we have no errors here, so let's try to plug this in. Alright, now I'm going to plug this one. So let me set it to virtual machine here. Okay. Alright. Okay, I have port now set up. So let's assume this one works. So this is the file. Now I'm going to upload this one. So it's uploading now. As you can see, now it's turned off. So as you can see, now these bulbs are blinking for this pattern. Alright, so this is the highest value, so you can see the highest value here, and the two left and two beginning and the ends are 0. Alright, so you can see the highest and lowest. So this is 1 second of time that we are going to see. So this pattern is 1 second long. So this is the end of this video. So here we successfully programmed the Arduino part, and we successfully wired the connection. So everything here now working as expected. So in our next video, the C# program generates this file, this pattern file, along with this next pattern method. Alright, so it automatically fills stuff from the bitmap file that we are going to generate from the Photoshop in next week, and fill this array, and this one also changes, and rest are same, and this file on the other hand does not see any changes. All this does is call for next pattern and fill these pins with PWM values, and it delays. So this loop runs, and this is the one responsible for uploading stuff. Alright, so that's the end of the video. this part. So thanks for watching, and thank you very much for staying with this. So in next video we are going to discuss the final part, that means implementing the C sharp program and Photoshop code, Photoshop converting the Photoshop image file to the pattern file. So with that being said, I thank you very much for watching this video, and don't forget to subscribe to my channel. It's Fun Text with Hashan, and also click the bell icon so you will be notified when I uploaded a new video. So again, thanks for watching, and thank you very much.